GM, hello. It's amazing to be back. Every Friday we have this show now, and I'm really excited. There has been a lot of positive feedback last week, and it's going to be, again, very casual, hopefully very interactive. So if you have any questions, go to Twitter, Twitch, YouTube, any platform of your choice, and feel free to join the chat and ask questions away. And just a quick recap. Last week, we started building this small to-do app in Rust built on chain. So we have our to-do items and the rules of adding and removing to-dos fully scripted as an application on chain, on Near. That is where we will start off today. I will quickly recap what we did last week, and I promised that we will dive a bit deeper with this topic this week. So I want to cover the topic of Rust collections versus near custom collections topic, and I will also try to cover the multi-tenancy setup, because currently the smart contract is tailored towards basically maintaining a single list of to-dos. So anyone can add to-dos to the list right now, and anyone can see them, and anyone can rearrange them. And the last but not least is a privacy topic. I think I will only have time to briefly mention it today, but there was a pretty nice discussion with Sandy from Calimero, who wanted to join and to talk more in depth about this topic for blockchain space. It's a hot topic. So yeah, and I would love to invite Joe at some point, and I want to also make it very obvious that I'm not alone here, and it's very helpful to have the community behind us and behind the whole initiative of DevHub, and Joe helping us to organize these calls, organize DevHub Live, and many other events, online events in Near space. So that's amazing. And obviously he's also building on Near, so there will be a lot of wisdom and potentially questions that he can ask and slow me down when I'm going way too fast with no context, because it's obvious for me. So it would be great to have more folks voicing it. But also, yeah, don't hesitate to ask questions in the chat. I hope they will appear on my screen, so I'll be reacting to those. Cool. Where should we start? Let's start with the short recap of where we were standing. So I created a new project last week using Cargo Near extension. So if you go to Cargo Near GitHub page, you will find a way to install it. It's super simple. Just choose your platform where you're using it, and then cargo space near, and you will have all the nice subcommands. Cool. After that, it creates basically all the boilerplate for the pretty standard Rust project with just a bit of flash to it, with reproducible builds and stuff. And obviously with the latest SDKs, actually the latest is 5.5 already, but it's fine for us for now. We also covered, so we built the contract, the very basic version of it, and we even had a test added to it, the unit test. We didn't cover the end-to-end tests. I'm not sure if we will this time. We'll see. But nice part about it is it's also available off the shelf, and you can basically run the full local net blockchain as a sandbox environment, and then compile, deploy to it, and do all the stuff with your contract there. And just to remind you, the interfaces there there was a contract that is the root state of the application, basically. We had a list of to-dos in the form of hash map, and we had an identifier for the next to-do that we want to store. We also discussed that there is a to-do item with its status, completed or pending, and we added the methods to initialize the state and add the new to-do. Currently, as you can see, there is no checks who can interact with the contract. So anyone can call the method add to do, and we will just obey and insert the to do in the list. But it could be easily changed, and we can add owner with the contract, and we'll strictly define who can. Anyone can call the method, but not every request will be fulfilled. So that's it. Then we also introduced the listing the to-dos. They are all public, so anyone can list our to-dos, also permissionless. We can change the to-do status. Obviously, currently there is no safeguards who can change the status. Not very helpful in a way, but at the same time, why not? So it's up to us to define all those rules. And that is why the applications on chain were initially called contracts. So we kind of defined the contracts, like legal contracts with code. And since the execution is not controlled by any one party, that becomes a contract that is controlled and ensured through not through the lawyers or bureaucracy, but through the programming code and the decentralized network that has certain rules that the network has to follow. Otherwise, the nodes would not be rewarded, would not be part of the protocol. So there is no real point to not follow the rules. You would not gain anything out of it. Cool. And today, just and how it worked. So we did cargo near, and we built and then deployed the contract. I think it was I'm using visitor. Let's check. So I will go to near blocks to as always, if it's live, it will go run, and all my attempts will be blocked at any point with unknown errors. So look, near blocks is already not loading for some reason. Let's see if the lightweight Explorer works. Testnet. Yep. Great. Single access key, 10-year. Let's see. We don't have the history of transaction handle on the lightweight indexer. 7 days ago. That's exactly last Friday. So yeah, let's keep going. Hey Joe.
What's happening?
Oh, a lot of stuff.
Yeah, I've been watching. I'll just let you go, and I'll chime in as it makes sense.
Amazing. Yeah, thanks. because it feels a bit more relaxing and human to me than just monologue.
Yeah, for sure.
So I'm using visitor testnet is the account where we wanted to deploy and we deployed the contract last week. I'm not sure if we used the reproducible build last week. Let's check. So I'm going to contract. You can see contract code, and it seems like it was either not contract source metadata. Let's quit it. Okay, we actually built it with the reproducible build details, but I think the SourceScan only was enabled for testnet right after the call. Let's. I didn't try. Let's see if we can push and ask it to verify our contract. What it does behind the scenes, it basically reads the data. It makes a view call to my contract. Which one you may ask? So let's see. Contract call function as read only. I'm using wizard, and the name is this contract source metadata, and no parameters you need to specify there. So, and it's testnet, yeah, latest data. So this is what SourceScan basically fetches, and as you can see in the output of my contract, there is a baked in hard-coded metadata that is very helpful that allows anyone to pull exactly the version of the code, exactly the build environment, which is a Docker image. And well, given that we use it from the root of the repo, the contract path is just blank, meaning root. And with the command cargo build inside this build environment, in this working directory, with this source code, it should get exactly the same WASM file. And this is how it then confirms that, yes, actually, the source code matches, and if so, contracts verified successfully. That's what you will see. There's a lot of work behind the scenes has been done to enable all of that, and I'm very happy to see it live on testnet as well. So as you can see, we can now clearly see the exact smart contract that we are dealing with. Nice.
So why, just so for people to understand a little better, why is this important? And and as we talk about interacting with blockchain and stuff like that.
Exactly. Well, very good question. Thanks for raising it right away. The reality is that, as I just mentioned at the very beginning, the applications that are on blockchain are called contracts. Why so? Because they can guarantee certain rules and certain logic and gameplay in a way of the of the interactions. So you can define that anyone can add it to do, or no one can add it to do, or only some people with some amount of tokens can do certain things. And for this contract to be, truthful and the one that you can rely on, you need to verify that the application that is stored on chain is actually the one that you believe the contract is written, like text reflects of. And the smart contracts on Near are WASM files, so they are WebAssembly binaries. So they have just program code that you deploy to the chain and not the source code. And this means that it's like it's not for humans. They execute efficiently. It works beautifully and fast, but you cannot really read that code. You cannot read that contract anymore. So what this feature is about is how to link back the binary that is deployed to the and published to the blockchain back to the source code that is more human readable, and we can review it and understand the intricacies and rules that are defined in the program. And this is why we need the source code. But the challenge is you cannot generate the source code back from WASM file anymore, and the source code is decoupled from the WASM file overall. So our only way to get back to the source code is actually confirm that if we build the source code, if we build the WASM file from the same source code again and get exactly the same WASM file, that means that the source code matches the WASM file. And a way to do it is to well, I can now, based on the based on this information that is baked into the WASM file, I can reproduce the I can literally git clone Carganeer build in that folder, and I will arrive to exactly the same results. And if so, I can locally verify it. What this UI helps like how this UI helps us is that it does it behind the scenes automatically for us and just publish the results here. That's why you can see the drop down here. It's not just one source. You can become another source of validation in the future. I'm not sure how exactly you can join the program here, but I'm sure there's like it was designed to be verifiable through several lenses. So they will do exactly the same process, reproduce it, and they post the result into the smart contract in this case.
And this is where, so in Ethereum, if you come from there, so people have always asked, like, why can't we see the contract code just like you could in Etherscan, right? So this is kind of giving that same thing, but at the same time, it's also essentially signing off on that this is the right person who said this. You know, I almost feel like this is a step further because there is a source that is validating what's there as well to match that up.
Yep, exactly.
Cool.
And it's all about tooling and the features. So we could imagine that the source code would be published just like in the Ethereum world. We could publish the zip archive of Rust project onto Near, but then the validator node would need to do an expensive compilation step, and each node would need to do that, and you would need to strictly define the build environment there. So that's why the Near protocol decided to go, okay, well, just upload the WASM file that is good enough for us and solve the problem of verification and ensuring the match of the source code somewhere else. And this is was the pain point that SourceScan team identified, and they pushed for it for over a year. And finally, we have the fruits out of this tree, and it's amazing.
Yeah, very cool.
Cool. Yeah. So let's talk about this topic of why standard. So well, let's go back a bit. So here, not here. Sorry. In our contract state, we currently store to-dos as a Rust std collections hash map story object. And this means that we basically store them in the same blob of memory, and we serialize them all at once. So every single time the application is a contract is called, a function call is executed, the the self, the contract storage state should be deserialized, and then only then the function will be executed. And then after we return from the function, these changes made here will be serialized back again as a single blob of data and stored on chain. So in the essence, actually, if we go to nearest rs and open the I want to open the tests. Here's the compilation test, no tests. Maybe not need. This one should work. That's one, but I want to have code generator. Maybe not the best way to demonstrate it after all. Arc parsing. Where's tests? Sorry about that. Let me quickly open the tests. Here we go. So there is a test case in nearest rs, and I think it's very important to understand this bit of thing, because that will just open all the doors going forward. This is a test that verifies that what the code will look like after we feed it into the near macro. So the public method fn with the name method and self and k as a string. So this is one parameter, and for example, no body in it, will end up with. So after the code generation step, we want to see what's actually inside. And on the last video on Friday, I showed you this beautiful instack rate that generates the snapshots and stores them. So if we open basic JSON as basic JSON file, this is the source code, the Rust code that is generated for the function call. So it generates a standalone function. Then not here. It shouldn't be ext. I think it's this is fine. Yeah, our parameter is simple int. Don't worry about the changes. So what it generates, it generates a method. So it's a function method, which is marked to be no mangle C and only for target wasm 32. All you need to know is that this method just becomes part of the publicly exposed methods of the wasm binary. That's all it does, exactly with this name. So it doesn't change it, because usually compilers will change it for the reasons to not collide with any other method, with other functions in the user code. In this case, we want it to be exactly this name. What it does next, it does set up panic hook, but it's also not important here. It also generates a struct. It's easier to read it if we imagine it's actually top level. Imagine it's here. So just a struct called input. There is only one parameter, and then we apply serde deserialize derived to it. What we do then next, we call the nearSDK input function, and we try to and it will read the value from the state, its local state of the application, and deserialize it from JSON in our case, because we use serde, into input. And if the result, so if input is there, it tries to deserialize from slice the input string, and if it's successful, if okay, then it returns this deserialized value. Otherwise, it will just return the error that you see in the smart contract when you call it. We can already test this one. So failed to deserialize input from JSON. Where do you see it? If you call any contract, in fact, built on with nearSDK res, so let's use my contract. Let's call list to dos. We specify, instead of JSON args, let's use this text args, so it's free form, and we put some nonsense here. What we expect to see is exactly the error I just showed to you. Okay, so given that the function doesn't care about any parameters, it just ignored it. Let's use the one that add to dos, for example. Contract call add to do. If we do not comply with it, with the JSON requirements. So as you can see, failed to deserialize input from JSON, exactly the string that we see here. So this is exactly the code that takes care of it. So the function add to do was wrapped, and this was the preparation step. So it parsed the input parameters first. We have the input now. And now we have the one more line. Let's get back to it in a bit. And after that line, we have the hello, so our contract and method add to do executed right this way. And we pass the contract. We'll come back to it in a bit. This is this line. And k, which we just parsed from the input. So this is nice part. What's contract? Contract, on the other hand, so let's call it contract in our case. It's a what do we do here? We call nearSDK env state read, and then we try to if there is an error, we just call default implementation to it. So we want to generate a contract. So basically calling a contract default method if there is no value there yet. But what state read does, we can look it up here. XRS nearSDK read state is very thin, very small function. Where is it? State read, sorry. State read. So state read what it does storage read, state key, and if there is an error, do something cannot deserialize, blah, blah, blah. So it tries to deserialize it at once, whatever it read from the key, state key. What is state key? State key is just this string, state. Let's look into it, actually. So near contract, we can view storage. I'm using visitor. And which keys do we want to see in the storage? All. And let's present them as text for now. So it says that there is one key in the storage, state, and there is a nonsense inside. So this nonsense is actually Borg serialized hash map of probably two values, if I read it right. Each, like there are two keys. One key is test to do app, and another key has the to do of test to do app from CLI.
So before I want to just kind of help clarify some things here too. So part of this, in the way that state works on near, is that so contracts are upgradable, right? And we can, they really truly actually almost act like a database, because I can read, write, I can essentially remove content because I'm changing my state, right? I can even change the structure of my state. I can actually upgrade my contract to have a different structured state. So this basically is one of the unique properties here, that is how you can start to leverage a near contract to really serve as your backend, right?
Yeah, so that's one aspect, and also this allows us to hot swap in a way the code at any point in time, and it will continue using exactly the same data that is already there, and you don't need to if you need to update the data that is in your local storage, that's up to application. So your contract should take care of that. But if your app is only changing, the rules who can interact with data, but not changing the layout of the data, then no changes to the data, so-called data migration, is not needed. But what I was trying to show here, that basically on every interaction with the function, the deserializing of this state value happens, and then after the end, I think it's not in this example, no return. There should be. So value return, this is another thing that we didn't cover. So when we call the method, we want sometimes to return something, and this is the code that adds adds it basically. So it serializes the output as JSON to a vector of bytes, and then calls a host function value return. But what's more interesting is this thing. So basically, if your function is mute, it uses self as mute, the code that is generated for your contract has this line at the end. So it executes your function, and then it calls a state write to store the value back, and the value is your contract structure that is serialized to Borg, and then bytes are stored on chain. And this means that the bigger this thing is, the more compute power is required. And if you have thousands of to-dos, you will have a bit of a problem here. And we have a very good documentation in this in NearSDK collections, or actually not. I think it's in store. Oh, how did I end up here in store? Maybe in the lookups. How come? Iterable. Map. Not as prominent as I would expect it, to be honest. Let me find it from the code side somehow. Is it the latest? It's latest. Store module should be there. We'll need to fix it, but we do have the documentation. We do have the benchmark, which shows that after a certain amount of records, we see a degradation in performance, and it will, like the growing number of records produces more and more gas. That is like that is equivalent of compute power that is required. So after after 1K, we have, if we only use the contains. Oops, did my sharing the screen failed?
Yeah, it went away. You have to re-add it.
Do you see?
There we go.
Yeah, so after like 1K, you already see that native. So before 1K, if we call contains on the collection, contains is either a key in the collection. If the collection has 500 elements in it, and we call, if it contains number 40, for example, native collections give you will require more compute power, but not substantially more. But going from after 1K elements, it becomes even more obvious that there is an overhead, and with 100K elements in the to-do list of these are just integers. If we have strings, it's even more penalty there for sure. We already see this gap of access to the data and confirming that it's like just doing this basic operation, basically. And that is because we encode we have to serialize and deserialize this state at every function call we interact as through a transaction or cold start. If you interact internally, like if the contract calls its own function within the same transaction, there is no penalty on that because there is no serialization happening. But when it's a cold start, it does require to initialize the contract state, the memory, and this is the problem you may face. So in our case,
go ahead. I was going to ask a question, but actually keep going for a minute, and I think I might have a question for you here.
Yeah. So in our case, we do have like until we have, I would say 1,000 of to-dos, we're good. How many of us do have 1K to-do list benchmarks? Not many, right? So sometimes it makes a lot of sense to actually use just Rust native collections, and it wouldn't be a huge problem. But if you are building, for example, NFT or FT contract, where you need to keep record of a unbound list of records, and that could be millions potentially if you have a successful NFT contract or FT, and you have a bunch of users, then you need to use these collections. And what's the magic there? There is no magic behind it. They just use the individual storage keys, so local storage that you can use as part of the near API. You have two methods: read, state read, and state write, and state exist if you like. So these are the functions that you can use. You just hold on, not state, storage write, and storage read and storage remove. These guys. So storage write expects you to give a key as a bytes array and put the value as bytes array. So you can put this is how you can use it. Similarly, to read the data back, just use storage read. You specify the key, and you get the value back. So those iterative set, lookup set, lookup map, all those store collections. So in store, we have a bunch of them. So for maps, for sets, and for just some values that are big and you don't want to put them immediately. So we want to keep them as a separate key. That's the way. And vector obviously as well. So these are just a small wrappers around the those storage read and storage write operations. If you want to understand more in depth, I would recommend you to check out the deprecated collections implementation. It's much easier to understand. So if you go lookup map, for example, lookup map and go to the source directly, it's really not that big. As you can see, it's those are tests. So the whole implementation is just 200 lines. And what it does, so it has a method. It has a method, for example, contains or get. Let's use get as an example. Get is just a get raw, which is a method that expects a key as a byte array and returns you a byte array. And it just serializes the key and deserializes the value. That's all it does under the hood. So you don't whenever you store objects. So the collection is just it knows the types and it can serialize and deserialize the values of those types. Yeah, Joe, you wanted to ask something?
Yeah, I was going to say so. One of the things that I think comes up is you see these limitations here, but obviously we can deal with a lot more data, right? So some live examples are like we're at the near social contract.
Mhm.
The NFT contract that we have on ShardDog has a ton of data in it. So what is actually happening, and how are we able to actually program around those limitations?
Yeah, let's maybe jump into a quick example here. Not this one. Here. Let's change the collections here. So let's use near SDK store iterable map and see what it will actually require us to do. So first of all, it will fail to compile. It will fail to compile because we have the initialization code here. Okay. Here we need to use also, obviously, near SDK store iterable map new instead of hash map. But also it will fail to compile because it requires a prefix. And this is a thing that like we need to maybe stop for a bit to think about what this prefix could be used for and why it's here. As I said, these collections are using read key, storage read, storage write operations, and they basically just expect the key and value, like the keys. They share the same. They use the shared local storage of your application. So if you have several collections, how to distinguish the keys inside those? There is no way for the app to know. That's why we need to prefix all the keys this collection will use to store the on the local storage with the specified unique key. So in this case, it could be to do. Let's prefix it with just simple T. Let's see if to do will also recommend T. And this way it will compile, and we can already deploy it. Cargo near deploy. But there will be another problem. Not this one. So this one is about reproducibility. So this is it complained that the changes are not committed to Git. That's why it cannot actually encode the reference to the exact source code. I had to disable it for now, just to speed up things. In production, I do recommend always to deploy with reproducible builds. Another question that it asks on deployment is, will we need to initialize our contract again? And our contract is already deployed and the state is already there. That's why we don't want to initialize it. And while we do this, let's see what will happen. We'll hit another problem. Not on deployment. Deployment went fine. It's all great. New version of the application is there. But whenever we will interact with the contract, contract call function read only my contract, for example, list to dos, no parameters. Yeah, it's all great for now. Now it panics, and it says cannot deserialize the contract state. And that is exactly the problem we discussed just a bit ago with Joe, that when you deploy the code, you can rewrite, update the code, but and while keeping the data right there. So the data contract view storage on this account Yes, viewing all the keys. Testnet, yes. Now data is exactly there. Like it's still two to-dos we added last week. Nothing has changed, but the code has changed. And how exactly it has changed? Now the contract state uses a different collection, and this different collection has different way to serialize the data. So how do we fix it? So there are two ways. If you need the data to be preserved, you need to come up with the function in your contract that will be allowed to be only called once and only by you probably, or by the operator that will take the old data format and put the new data in a new format in the storage. In our case, for development purposes right now, I will remove the account and recreate it from scratch. In your case, so if you want to dive deep into this topic, I can recommend you to check out the DevHub contract. There is a lot of interesting ideas already put here. So there is a migrations RS file, which handles all the previous iterations. As you can see, we migrated from versions to versions to versions, adding more fields, adding more like details to it. And there is a code that reads the state and then applies the changes, somehow mapping the changes, and then storing them back, inserting state right. So this is the place you can learn more about more complex way building the migrations for the prod apps. In our case, I will probably just actually create a new dev account for testnet. Yes, create. And we'll deploy the code there. Also for our reference to compare, I would say, files likely make what? Oh, it's not from here. I'm not deploying the nearest DKRS, obviously. Sorry, lost in Windows bit. Save, deploy, yes. And in this case, we do want to initialize it because this is brand new account, new contract. So we need to call new with no parameters, and it will initialize the state value. Let's do that with init call, no parameters, no changes needed really. Sending transaction, boom, it's there, super fast. Let's compare the state. Let's view the storage of this new contract, all keys as tags on testnet now. You can see that the state is there. There is this T and TV and TM. So actually, the underneath of the iterable map, there are two vector implementations, one for keys and one for values. But you don't need to really care about it. But let's add something to it now. So call contract as transaction. This is the contract that we want to call. We want to call add to do. We want to provide the parameters. Text is a new nearest the case for to do. And that's what we are adding here. So this is our to do. Nice. Let's see it here just to make sure that add to do was called with this text. Nice. Everything is fine. And we can view the store now. Contract, view storage of this account as text. No? Cool, look, now we have 3 keys. So the key of state did not grow. It actually remained the same. But the new keys were added. So one key is this nonsense there. Let's get to it a bit later. And there's another key. And if I like, I can read it because I'm used to be a machine. But the reality is that there is a TV is just a byte prefix. These are also bytes, and as you can see, they are 0 bytes. So these are 4 bytes, which actually represent the to-do ID, which is U64. U64 takes 4 bytes, and this is what we see. And the very first to-do has the byte that has like number 0, and this is the very first to-do. And what it references to? It references to the key in here. What this thing is happening here, I'm not particularly sure right now. I will need to think a bit more about it. But this is our text to do. So this is our to-do struct serialized to Borscht. To-do struct is a string and a status. String is serialized in Borscht as length, so 4 bytes of length of the string and the string itself. And then the to-do status is the enum, which is just I would expect it to be 1 byte, but let's see. So going back, this is our length, so it's 18 characters. This is a string. I assume it's 18 characters long. Maybe it's plus 1 byte end of line, and then the status. That's probably how it's serialized there. You don't need to parse it this way usually. It's there just like I just wanted to show and present you that there is no magic behind it. Just literally, it just has it there. If you need, you can, but you usually don't need it. But back to the question of growing number of elements. So if we go and call function as transaction again, add another to do text, another to do, we will see that the state will not grow. Well, let's copy this handy command. The state key remains exactly the same. Actually, it does change. I forgot. It actually keeps track of the number of elements. So we know that there are 2 elements. So the state is updated, but it's only updated like just the incrementing the number right there. And the individual records of to-dos is stored separately in under unique keys.
Awesome.
So yeah, well, there is a balance of using near collections and Rust collections. Ideally, I think we need to come up with even more balanced type of collections where we can batch, hundreds elements into it, into one batch of under the native key in near, and then it would get benefits of 2 worlds the best. So far, we don't have the contributions on that direction, but I think eventually we will arrive to it with even more usage and even more optimizations needed. I think some of the projects already implemented it on the application level, but it would be beneficial to also implement it on the SDK level. Okay, I hope that is more or less clear. If there are any questions, shoot them. But I want to briefly touch these two topics. Multi-tenancy. So currently we have the anyone can add the to-do to the list, to the shared list of to-dos. So in order to make it, and this means that with more users, you will basically reuse the same list of to-dos. Not very helpful. But what you can do, you can approach this problem with two ways. One, you can say that, okay, this contract only belongs to one owner ID. So only the owner who will initialize the who will call the new method, only that user will be able to use this contract. Or you may say there are owners ID, so it's a vector of those people, and you can add methods to who will be able to interact with it. But those owners will still share the same list of to-dos. This is what happens with NFTs in a way. Like NFT contracts on Near usually use this approach, and then but then you need to keep track of the also like owner in each to-do, in each NFT. So it could be NFT, could be to-do. And then you need to verify whenever somebody wants to change something about the text or status of the to-do, you need to just first verify that the owner is the right person. Or you verify it on the top level of like all to-dos only belong to one owner or list of owners. And then you basically, how you scale it, you deploy the same contract to multiple accounts. So each user needs to deploy their own version. This approach is used by Sputnik DAO tooling usually. So the DAO has the like controls of who can interact with the contract, what are the rules. So that you add the proposal, you act on the proposal, but that's a shared ownership of something inside. So the DAO usually has like tokens sent to the DAO, so they control the token allocation, and all the people who can do something with it, only them can define operate within the logic. Another approach is the like NFT approach. Going back, is when there is only one contract and there is no owner. So there is owner for like upgrading the contract per se, but overall there is an owner on the individual element. And then each operation just requires you to validate if it's allowed or not. And then you deploy it as a single contract. You don't need many of them unless you want to shard them. And this one contract needs to be like it needs to control, be very carefully scripted, so only owners can operate with these entities, and nobody like. So it's pros and cons of each of those approaches. When you have a contract per team, per person, it's more expensive because you need to deploy the contracts over and over again for like all your needs, or more each individual user will need to deploy their own version, but they are in full control of the version of the code, of the operations it can handle. Whereas with shared contract, you have the limit of there's probably either no updates possible at all, like you don't want anyone to even have control over that process, or it's cumbersome, and there are some risks associated with that. The risk is the upgrade will be vulnerable. The risk is the upgrade will be broken and the contract will not be able to return you any values anymore, and you will need to query the data back in time and restore it from there and maybe create a fork of that contract. So there are challenges, but they are overall reasonable, and it just like challenges of the software engineer world. They're not like unique for NIR, I would say. It's about hosting a website. Either it's, is it a Facebook where everybody comes and it's a single platform and the users are co-hosted there, or it's a like web where I have my own personal landing page, Joe has his own personal landing page, we have different domain names, but we could use the same software to generate those pages, like static site generators, or even Facebook as a software if it would be possible. So nothing unique here, but I just wanted to highlight that you need to pick your type of cure here.
One piece that might be, I think, though, is different that people might not be used to if they're new to blockchain is the concept of storage costs. Because, and so in your scenario, there's a couple of things that can happen here where if it's a shared contract, the contract owner could cover the cost for everybody and all their users. There is a way to do that. But you can also have the end user also pay for their cost of their own storage. So that's something too that is a consideration in both your contract design as well as like the decision of like, again, is it a single contract? Is it going to be multiple, whatever that starts to look like? Those are considerations. Now with the to-do app, it's minimal data, but it can get large pretty quickly, especially if you deal with even just NFTs and like larger metadata. It can certainly grow faster than you think.
That's true, absolutely. And this is a huge topic to discuss as well, the gas and the storage costs and storage in general. There's nothing free in the world, and we need to compute is costs money, storage costs money, traffic costs money, and not only cost, but it's like it's a work some systems are doing, and it's energy. That's why usually we measure it in gas points, like a reflection of energy points. Totally probably good topic to cover maybe next Friday. We'll see. On the privacy topic, I will only cover it briefly. Joe, are we in touch with Sandy? Are we ready to
yeah, I think we're good to go for next DevHub Live next Thursday.
Next Thursday, 4 p.m. UTC, right? We'll have a huge debate on the privacy topic in the blockchain space. But today, I want to say that it's fairly simple and fairly complex topic at the same time. So privacy is like, there are many faults to it, and it's a deep dive on on the number of ways how things can go wrong on the protocol level, on the application level, and everywhere in between. The one thing that I want to say, from the get-go, if you don't want something to be on the internet, don't put it there. So if you put something out there, you need to be ready for the fact that somebody can read it, even if it's not blockchain. But in blockchain, it's just more obvious and clear that whatever you put on the blockchain, it's public. So what you need to consider that these to-do lists, to-do items, will be available to everyone in the world immediately in 1 second after we publish the transaction. In 3 seconds, it will be finalized. So it will be, carved in stone. However, it doesn't mean that the data has to be plain text. And this is where cryptography is very handy. What you can do, you can store encrypted data. So instead of putting the to-do items as encrypted or as plain text data, plain text, you can put them as encrypted blob of data, which, unless you possess the key to decrypt, you cannot read. And there is a huge challenge with that still, because with advanced in compute power, we still face the problems of, what if today we cannot decrypt it that easily without the key? How about in a year, in 10 years? Do we care about that? And what do we do with that knowledge? So this is hopefully the debate we'll have with Sandy next week. What are the solutions to this problem? Overall, for some use cases, I would say that it's totally fine to keep the just encrypted data on chain. Totally reasonable use case. I actually played around with it for certification programs. So if you want to give some sort of certificate to a user and you don't want to reveal their personal information, that could be a good way to go. So they can decide who they share the certificate with, and that shareable link should just include the key to decrypt the data. It was a nice, cool experiment, and it works very well. We just need to probably have some primitives that make it easier to work with this direction. Yeah, I think that's all for today that I wanted to cover. Is there anything in the chat that we want to discuss as well?
No, nothing today. I think this is. I like the pacing that we're going at here, though, of putting all these pieces together here, and I want to remind people who are watching this that it's better to kind of go. If you didn't watch one from last week, watch that, see how it connects here with this one, and then we'll keep kind of building from there, because the better and deeper understanding you have of how this all works, I feel like it's easier to then go build on top of it. So that's
100%.
hopefully what they're getting from.
Yeah, definitely. Tooling on Near makes it very easy to deep dive into very neat details of many things. Still, you need to know what exactly you want to look at. I would imagine if you just randomly stumble upon into view storage and open this nonsense, especially of a bigger contract, you would have no idea what you're looking at.
Right.
I hope today we uncovered this mystery, and now we all can be machines and read it.
Yeah, absolutely. Perfect. Awesome. No, this is awesome. So let's just remind everybody. So this is again part of the Redacted Hackathon workshops, but we're going to keep going through even after Redacted is over. You have until the 31st to submit to the hackathon, which we are really excited about. There's over $700,000 in prizes here, almost at 1,500 participants. So it's really exciting. There's tons of stuff you can do. You can stack bounties. So take your time, go through that. Again, everything you're learning here all coincides with what's available there. If you are able to go, you're interested in going to the actual event in Bangkok, there's still some time to sign up for tickets. Make sure you're doing that. That's coming up really fast here. Can't believe we're at the end of October already. But yeah, just keep building. Come ask questions. We are available as DevHub and as developers in the different Telegram chats. Maybe I'll pull those up real quick for people so they can see those as well.
Yeah, and definitely subscribe for the newsletter. There is a lot of
Yes,
cool ideas shared by developers. We collect all of that together. Recently, there was a C library to interact with the Near blockchain, so you can
absolutely.
even use it on your router, on your network switch, and yeah,
Yeah,
build
the
network.
possibilities here. I mean, there's just so much that's going on, and we really want to encourage everyone to build as much as possible. So please do so. I thought I had an easy banner here, but let's. It's just simply here. Yes, riskless loss. Let's not forget about that. You want to talk about that really quick?
Yeah, well, it's a fun way to contribute to the open source as you go. No major changes to your flow. You just create a pull request. You go and tag Race's loss account, and you will be greeted with your nice badge with all your achievements so far, and the maintainer would be helping you to collect the sloss points by scoring the pull request you create with just it's just a reflection of kind of value and complexity of the problem you tackle. Overall, I think all the contributions are valuable, but still, like, it's just a bit of a gamification process here that you can you know add a bit more sauce to your day-to-day
Yeah, absolutely.
life. Yeah.
For sure, for sure. Yeah, so check that out. I added the link to the Telegram chat for developer support on the screen, so guys, check out that as well. Come in, ask questions. There's no bad questions. You know, between the DevRels here through DevHub as well as just other builders in the community, someone's going to be there to help you and answer your questions. And so jump on in. We hope to see what you guys are building out there. So again, we'll see you. We'll be back next week. But until then, keep hacking away. We'll see you then. Bye now.
Amazing. See you.